I'm Anil Kumar. Welcome to my series on vectors. Here is another very interesting example based on intersection of three planes. So we are considering intersection of three planes whose equation is given here. 2x plus y plus z equals to 4, x minus y plus z equals to k, 4x plus by plus z equals to 2. We have three parts to this question. First one is find the value of b and k for the system to intersect in a line. B. What happens if the value of b is changed in A? C. What happens if the value of k is changed in A? You can always pause the video, answer the question, and then look into my suggestions. Now let's look into the concept. So part A is we need to find the value of b and k for the system to intersect in a line. It really means that if we are working with augmented matrix, we are looking for a situation which could be something like this. Right, so we can have 0 here, some number, but we're looking for a situation more important, 0, 0, 0, and if you get this situation, that means the intersection is a line, right? So this means we are looking for line, which means infinite solutions, correct, which is part A. Now if we change the value of b, which is right here, which affects this position, right, then what happens? So in part B, if we change the value of b, then the situation might become something like this. Right, so we'll just keep the rest. These are any numbers, right? So if I change this, we may not get 0 here, right? That's the whole idea. So we have 0 something here, 0 equals to 0. Now definitely we have in this particular case one solution, right? So we have a point as our solution, correct? So that is part B, and C is when we change the value of k, right? Then see what happens. So we'll have a situation which could be something like this. So we change the value of k. That means this value is something different, right? So basically, well, it will be some other point in that case, right? And here what we get here is 0, 0, 0 equals to 0, right? So that happens. So that may not change anything, right? So in this particular case, still we may get some other lines, right? We may get some other line. Correct. Now let's try to figure out the solutions. So let's begin with the augmented matrix to solve. So we have 2, 1, 1, 4. This is 1 minus 1, 1, k. And here we have 4b, 1 and 2. So the idea is to get 0 in these two places. To get 0 here, I will do 2 times r2, take away r1, correct? So then I can get 0 this place. And here I will do r3, take away 2 times r1, correct? So r1 will keep as 2, 1, 1, 4. Now 2 times r2, take away this is 0, minus 2 take away this will be minus 3, and 2 take away 1 will be 1, and 2k take away 4, correct? r3 minus 2 times r1, so when I take away 4 it is 0, 2 times r1, so b minus 2, 1 minus 2 will be minus 1, and here we get 2 minus 8, which is minus 6. Right, so that is what we get. Now the idea is to make b minus 2 as 0. So, or what we can do here is we can make this as 0, right? So at least we'll get 2 zeros, and then we can equate that to 0, correct? So we'll now write our system as 2, 1, 1, 4. We want to make this one as 0. So if I make this as 0, what happens? I can add R1 to R3, right? So we do R1 plus R3. Sorry, R2, because that is 0 plus 0, right? So we maintain this as 2k minus 4. Here when we add, we get b minus 2 minus 3, which is b minus 5. And when you add these two, you get 0 here. Add these two, we get 2k minus 10. Okay, so that is what it is. Now in this particular situation, since we got 2k minus 10 here, to get 0, 0, 0, that will give us a line as a solution. What will happen? We have to make b minus 5 as equal to 0. That means b is equal to 5. That is one case, right? And the second thing which we need to do is to write 2k minus 10 equals to 0. So we get 2k equals to 10, or k equals to 5. Right? So we get both values of b and k as 5 in this particular case. Right? So for a line, we get our solution. Let me rewrite this here, that for case A, infinite points means a line of intersection we get b equals to 5 and we get k equals to 5, right? Now part B. Part B of the question was, what happens if value of b is changed in A, right? So if b is not equal to 5. So if b is not equal to 5, is not equal to 5, in that case, what will happen? Means we are keeping 0 here, right? So in that case, we'll have a situation which is kind of like this. We'll have 2, 1, 1, 4, right? 0, minus 3, 1. So this we have placed as 5. So it will be 10 minus 4, which is 6. And here we have 0, but some other number, not 0, right? Some other number, not 0, equals to 5. This is 5. So 10 minus 10 equals to 0, right? So definitely we have a point as a solution, correct? As expected, we get a point as a solution. So we get one solution. Is it okay? Now, let's consider part C. So let me do it in a different ink. And part C is that k is not equal to 5, but b we are maintaining as 5, right? So in that case, what happens? So if k is not 5, then we get 2, 1, 1, 4, right? And here we get 0, minus 3, 1, some number, right? And like we got some number last time. But in this case, we have 0, 0, 0. But since there is k here, and k is not 5, we'll get a number here. Right? So after going through this solution, now I realize that there is no solution. Clear? So this type, these two lines, they will intersect in a line, correct? So what we have is a trapezoid. So there will be two lines which will be intersecting in this particular case. So the type of solution is we will have a triangular prism. correct? So we will get triangular prism. System will be not consistent, right? So in this case, let me correct this. Since that will not be 0, it will be equal to some other point. So here we'll get inconsistent system. And it will look like a triangular prism. Is that clear, right? As we have seen very clearly right here, right? Since we have k here at the end, and so we have 0 is equal to some number, which is not possible. So the system is inconsistent. Okay, so let me push this a bit here. So it is inconsistent. So two planes will intersect in a line, but third one will intersect in a different line. You get the idea, right? So it will look like a triangular prism. So I hope the concept is absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best. I'm Anil Kumar. Welcome to my series on vectors. We'll understand how to find intersection of planes in this particular example. The question is, for the following system of equations, determine the values of k which result in one solution, infinite number of solutions, and no solution. So we are given three planes here. You need to find the value of k for which we could have one solution, infinite solution, and no solution. Well, when we say infinite solutions, we basically mean that it will be a line, right, which is common. These planes are not coincident, and therefore we cannot have a plane as a solution, correct? Okay, so let's use the augmented matrix row echelon method to solve for and then find the value of k. So writing this as an augmented determinant, we get this as -5, 1, 2, and that is -1 for us, right? Here we have 3, 1, 2, 1, and the last one is 6, 2, k square is the coefficient of z, and here we have the term k. We'll go for infinite number of solutions. We'll make the last row equal to 0 and that k also equal to 0 to find the solution. So that is the strategy. Okay, so first step, let's try to make these two numbers as 0, right? So what we could do here is in this equation we can do 2 times r2, r3 minus, we can say r3 minus 2 times r2. We could do that, right? Okay, 2 times r2. So we'll keep the first one same, which is -5, 1, 2, sorry, -1. Okay, we can also simultaneously make this as 0. So we'll do more calculations. To make this 0, I have to multiply that by 5 and this by 3. So what we are trying to add here is 3 times r1 plus 5 times r2, right? So then we can make this as 0. So we'll do two things simultaneously. Okay, so so here we do, when we multiply, we get 15, and this is also 15. By adding, we get 0 as expected. Now if I do this 3 times and this as 5 times and add them up, in that case I get 8 here, and here 3 times 2 is 6, 5 times 2 is 10, and so we get 16 here. 3 times this is -3, and this is 5. 5 minus 3 is 2. Is that clear, right? So that is how we are going to get this one. And now here we are multiplying this equation by 2. So if I do that, I get this as 0, taking away. Now 2 times this is 2, and when I take 2 from this 2, we again get 0, right? Now in R3, it is k square. Let me write here k square. 2 times R2 means we are taking away 2 times 2, which is 4. Now here we are taking away 2 times 2, which is k minus 2. So we did 2 operations, slightly more complicated. However, I hope you understand what we did here. Now the idea here is that we actually get infinite solutions when if we could make k square minus 4 equals to 0, and if you could make k minus 2 equals to 0. You get the idea, right? So if k square minus 4 is 0, then k is equal to plus minus square root of 4, which gives us plus minus 2. And here we get the condition k equals to 2. So as you can see, k equals to 2 means we get infinite solutions. Right? So if that is the case, if I put k equals to 2, then we'll get our augmented matrix as minus 5, 1, 2, minus 1, 0, 8, 16, 2. And we get here 0, 0, 0, 0, right? Do you understand? So this is for k equals to 2, and that gives you infinite solutions, since this is one parameter, which is a line, right? So this results into a line. Correct? Now, if k is not 2, but if it is minus 2, so this is case A and B. If I take k equals to minus 2, if I take k equals to minus 2, in that case what I get here is something like this. It's very important to understand this concept, and therefore I'm taking my time here. So we do get 0, 0, 0 here, but if it is minus 2, we get minus 4 here. Do you understand? And since 0 is not equal to minus 4, we have no solution. Correct? So k equals to minus 2 means no solution for us. Now anything else, so if k is not equal to plus minus 2, then the intersection of the planes will be a point, right? So we have one solution. So that is one solution. Is that clear to you, right? So that is how we could actually solve this particular question. So what we get here as our answer here is that for one solution, k is not equal to plus minus 2. For infinite solutions, k is equal to, which we found here as 2. And for no solution or 0, you can write k equals to minus 2. Clear? So that is how we are going to solve this particular question. I hope you understand the concept. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. I'll attach many videos in one list so that you can see how to work with intersection of lines, intersection of planes in one particular folder. I'd like you to watch that and understand the whole concept. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best. Here's question number 4. Determine the intersection, if one exists, and classify the system as consistent, inconsistent, independent, dependent. So we're given equation for 3 planes. If the solution exists, it will be consistent, right? Now, independent and dependent means if we have same planes or scalar multiples of normals, then they are dependent, otherwise they are independent, right? We'll use augmented matrix to solve this system. So let me rewrite the augmented determinant in this case. 6, 1 minus 2, we get 6, 1 minus 2 equals to 4. Here we get 1, 3, 0, 3. And here we have 0, minus 1, minus 4, minus 1. Now, we already have a 0 here. So first step, let's make that as 0. So to make this as 0, what we can do, we can multiply R2 by 6 and then take away R1, right? So this is what we could do. So just copy R1 as such, which is 6, 1 minus 2, 4. And here, 6 times 1 is 6, taking away, we get 0. 6 times 3 is 18, taking away 1 gives us 17. 6 times 0, so that taking away will give us plus 2. 6 times 3 is 18, taking away 4 is 14. And here we have 0 minus 1 minus 4 minus 1, correct? Now to get this as 0, we can multiply R3 by 17 and add it to R2, right? So we'll keep the first row as such, which is 6, 1 minus 2 and 4, right? The second one also same, we already have 1 0 there. Okay. Now we need 0 at this place, so we'll multiply R3 by 17 and then we can add it to R2, correct? So when we add, we get 0 here. 17 and 17 will make it 0. Negative 4 times 17, let's do it. So we have 4 times 17, and then from there we have to take away 2 minus 2, which gives us 66, right? So that's negative, right? So we have to add it basically. So we get 66 here with a negative sign. So negative 68 added to 2 gives us negative 68, right? Now here we have negative 17. When you add it to 14, you get minus 3. Well, that gives us a point of intersection, right? So that implies that we have a point of intersection. So let's calculate this point. So we have minus 66z equals to minus 3. So z is equals to 3 over 66, which is 1 over 22. So that is one value. And now we can actually solve for y. So we have 17y plus 2z equals to 14. So 17y equals to 14 minus 2 times 1 over 22, right? So we get, let's find out how much it is. So it is basically 14 take away 1 divided by 11, which is 153 over 11. Now we'll take that from, we'll divide this by 17, right? So y equals to 153 over 17 times 11. So we'll divide this by 17 to get our answer, which is 9 over 11. Clear? So 9 over 11 is the value for y. Now we have both these values. We can now solve for x. We get 6x plus y minus 2z equals to 4. So we have 6x equals to 4 minus y plus 2z, right? So we have this as equals to 4 minus y value is 9 over 11 and z value is 1 over 22. So we write this as plus 2 over 22, right? So which is how much? Let's calculate. So I'm using calculator, which is not a must, but you know, in this it is allowed. So minus 9 divided by 11, and then from here we'll add 2 divided by 22, and we get here equals to 36 over 11. So x is basically equal to 1/6 of 36 over 11, which is 6 over 11, correct? So we get 6 over 11 as the value of x in this particular case. So we have a point P whose coordinates are 6 over 11 for x, 9 over 11 for y, and z is 1 over 22, correct? So that is our solution. So we have a consistent system which is also independent, where the point of intersection is 6 over 11, 9 over 11, 1 over 22. Is that clear to you, right? So that is how we can solve the system of equations. I hope it is absolutely clear. 6. Find the intersection of the line x equals to 2 plus t, y equals to minus 2t, z equals to 1 plus t, and the plane pi is minus 5, 0, minus 5, plus p, 1, 4, minus 3, q, 2, 1, 2, where t, p, q are all real numbers. Now to solve this particular equation, to solve this question, we need to write the plane in Cartesian form. So as far as the plane is concerned, we are given two directions, right? So direction 1, here is 1, 4, minus 3. And the second direction given to us is 2, 1, 2. To find normal, we can do the cross product between these two direction vectors, correct? So let's find the normal for the plane pi. So the normal will be cross product of 1, 4, minus 3 and 2, 1, 2. So let's figure this out. So we get, we'll use this technique. We have 4 minus 3, 1, 4, and then we'll write 1, 2, 2, and 1. So these quantities will be positive, right? And the quantities in the reverse direction will be negative, right? So these will be positive. So we get our vector, which is going to be 4 times 2, 8, minus of minus 3 will be 11, right? Minus 3 times 2 is minus 6, minus 2 is minus 8. 1 minus 6 will give us minus 5. So the normal vector for the plane is this, right? Since we don't know the normal vector, we could write the equation of the plane in the Cartesian form as 11x minus 8y plus minus 5z plus d equals to 0. Now to find the coordinates of point D, we'll use the point minus 5, 0, minus 5. So we have 11 times minus 5 minus 8 times 0 minus 5 times minus 5 plus D equals to 0. So that gives us minus 55, that is 0, and this is plus 25 plus D equals to 0. So that gives us the value of D as equal to, when you take away, you get 30 here, right? So D equals to 30. So now we have equation of the plane in Cartesian form, which is, let me rewrite here. The equation of the plane is 11x minus 8y minus 5z plus 30 equals to 0. And we also know the Cartesian, the parametric equation of the line, which is given here. We can find the parameter t by substituting the values of x. So we now get 11 times x is 2 plus t minus 8 times minus 2t minus 5 times 1 plus t plus 30 equals to 0. So let's find the value of t. 22 plus 11t minus minus is plus 16t minus 5 minus 5t plus 30 equals to 0. Okay, so the t terms, 11t plus 16 minus 5 gives us what? Okay, so Let's use calculator. Okay, so we have 11 plus 16, and from here we'll take away 5. So as far as t is concerned, we have 22t, and the numbers is 22 plus 30, right? Minus 5. Okay, so we have 22 minus 5 plus 30, which gives us 47. Okay, so that is positive 47 equals to 0, right? So we added 22, took and then 30 is 42, and then we took away 5. Okay, so we get t as minus 47 over 22. Okay, well, divided by 22. That's it. So we get a value of t which is minus 47 over 22. Well, you can check the calculations, right? However, we'll go ahead with this and substitute this value t here to find the value of x, y, and z. So we have x as 2, the t is minus 47 over 22, right? So we get 2, which is 44. So we get minus 3 over 22. Okay, so that is x value. As far as the y value is concerned, it is minus 2 times. So it'll be positive, and we can write this as 47 over 11, and the z value will be 1 plus this, which is minus 47 over 22, right? So let's do this. We have 1 minus 47 divided by 22, which is equal to minus 25 over 22, right? So I'm not very sure whether these calculations are right or wrong. However, this is the actual method, right? So we do get a point of intersection, and the point of intersection between the line and the plane is for us minus 3 over 22. Y value is 47 over 11, and z value is minus 25 over 22. Correct? You may do your calculations and write down the correct answer in the comment. Here is the last question of our test paper, which is write a reduced row equivalent form of a matrix to represent possibility of 3 planes intersecting in triangular prism, right? So that means the planes are inconsistent, and 2 planes intersect in the form of a triangular prism. So what could be the solution? Well, the solution could be basically what we're looking for is the last row should be is 0 equals to something, right? So that makes it inconsistent. Does make sense to you, right? So the last row should be kind of like this, and that should make it inconsistent. But once we have this, then the other 2 should give us a solution, right? So we should have, let's say, 0 some number here, right? You could put any number, right? Let's say you can put anything here. So let's say a number here, right? A number here, or here also we have some number. Is it clear to you? So that should give you a solution which is for a triangular prism, right? So possibility is there. So that is kind of a reduced row equivalent form where we are expecting the planes to intersect as a triangular prism, correct? So that could be our solution. So I hope that makes sense. So that really means that the 2 individually, the planes are intersecting in lines, right? So we have, for example, we have a plane here, right? So let's say that it intersects another plane in a line here, correct? So let's say we have a plane going like this in front, right? So let's say we have a plane here. However, the third plane does not intersect at this line. The third plane intersects in a parallel line, right, with both these planes kind of like this, but at a different location. So one could be over here with this plane. The other one could be here with this plane. Do you understand? So that forms a triangular prism which you see here, correct? So that is what, well, okay, that is what it is, kind of. So that is the triangular prism which we are looking for. And so we could have an equation something like this to get triangular prism as our solution. So I hope that makes sense. In the next video, I'll take a few examples where we'll have actual values, and we'll see when do we get a triangular prism, when do we get a point, and when do we get a line of intersection, right? So that will take in another video. I hope with this you understand how to solve question paper based on lines and planes. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.